The chain rule. The chain rule is a powerful rule for differentiating functions that are compositions. And there's lots of functions that turn out to be compositions. What it says is that if y is equal to f of g of x, that is if y is a composition, then you get the derivative of y prime by taking the derivative of the outside function f prime, substituting in g of x, and then multiplying that whole result by g prime of x. Let's look at an example. Suppose we have y equals 3x squared plus 7 to the fifth. We need to identify what f and g are. G is going to be the inside function, f is going to be the outside function. F is the function that's done last, or the operation that's done last, and what's done last here is to raise something to the fifth power. So the function for f is something raised to the fifth power, and we can write that down using the variable u. F of u is equal to u to the fifth. We'll need the derivative. F prime of u is equal to 5u to the fourth. What's left inside here is the inside function, that's g of x. The 3x squared plus 7 is going to be g of x. So that part right there is going to be our g of x. That's 3x squared plus 7. We'll need its derivative, which is 6x. So now we can put together the answer by using this formula. Y prime is going to be equal to the derivative of the outside function, that's 5u to the fourth. So that's 5 times something, in this case g of x to the fourth. So we have this structure of 5 times something to the fourth. That's the derivative of f, that's the derivative of the outside piece. And we need to put into that g of x. So what goes inside here in between the parentheses is 3x squared plus 7. We put a 3x squared plus 7 there, and then we need to multiply on the outside by this g prime of x. So the last piece is to multiply on by the 6x. And that's the derivative using the chain rule. Frequently, we use the chain rule without writing down all these intermediate steps. So let's look at another example where we don't write down the f's and the g's on the side, but we just think to ourselves what they are. So let's look at this example. We have 6x squared plus 5x all raised to the fourth power plus 7 times 3x to the fourth plus 2x all raised to the third power. If we want y prime, again, the first thing we need to do is identify the function that's done last, just on this first term. We'll worry about the second term later, but just look at this piece. We have something raised to the fourth power. We take that something raised to the fourth power and we differentiate it, and that's 4 times something raised to the third power. The something in this case is the inside part, the g of x, which is 6x squared plus 5x. So we take 6x squared plus 5x and we put it between the parentheses, and then we multiply on the outside by its derivative. So g of x is 6x squared plus 5x. We multiply on by g prime of x. The derivative of 6x squared plus 5x is 12x plus 5. That's multiplied on by g prime of x. Remember, we have to have parentheses around this because it's the g prime of x times this entire thing. And then we add on the result over here. And in here, the outside function is 7 times something raised to the third power. Its derivative is 21 times something raised to the second power. Just bring down to 3. 3 times 7 is 21. 3 minus 1 is 2. The inside function in this case is 3x to the fourth plus 2x, so that's what goes here. That's g of x. We multiply on g prime of x, which is 12x cubed plus 2. That's the derivative. The derivative of 3x to the fourth is 12x cubed. The derivative of 2x, is just 2. And this is the derivative, and that's how you use the chain rule. Again, it's a powerful rule that applies to a lot of different cases where we have composite functions.